Humankind has done so for a very long time, gazed into the interminable gloom of the sky at night, filled with wonder and awe about the numerous cryptic secrets that, in the 1900s, lie beyond our world's reach. A theory proposed by scientists is the Big Bang to explain how the universe came into being, how it developed, and why it keeps growing. Despite the fact that this theory became widely supported, it has yet to provide answers to some of the most basic recent inquiries about the cosmos. Time's groundbreaking discoveries have made it even harder to solve these mysteries. In 2023, such a moment emerged when the James Webb Space Telescope from NASA discovered objects in the sky that appeared to date back further than the universe. This revelation, by itself, shocked scientists and sparked a contentious discussion. Do stars really have the ability to exist for more time than the universe itself? The discovery of the Webb has presented challenges to current perceptions of space and time, raising the possibility that our entire model of the cosmos may need a fundamental overhaul. These types of baffling inquiries are exactly what we'll be digging into. If you're captivated by the universe and have a desire to stay in the loop with new discoveries, be sure to subscribe and like. Also, activate the notification bell so that you never miss a moment. Roughly 200 light-years in a constellation far from Earth, known as Ophiuchus, lies a particularly intriguing star called HD 140,283. What draws people to this star isn't just its rate of travel on astonishing 4,483 kilometers per second. However, the story is buried in its past. Around 1 billion years ago, in the earliest creation of our galaxy, the Milky Way collided with a much smaller one, and this star was among the survivors of that cosmic crash. But the actual setting of HD 140,283 apart is not its route or speed. Rather, it's that it was given the name Methuselah in honor of the legend that has it, that a biblical figure has. This star was around for nearly 1,000 years. It is regarded as one of the earliest ever. Based on the observed initial calculations, its age is an incredible 16 billion years. This has been refined by more recent estimates to approximately 14.46 billion years, with an uncertainty of 800 million years. This still puts it older than what was thought, the universe's 13.8 billion-year-old age. As calculated utilizing cosmic data, this is microwave background radiation, which creates a perplexing contradiction. How can the universe be older than a star that includes it? In this obvious way, scientists have been compelled to reconsider how we determine the ages of stars and the cosmos, driving deeper investigation into these perplexing challenges. In order to fully comprehend this paradox, we have to appreciate the challenges in determining the age of stars. Like our sun, they maintain their fairness, the same temperature and size over very long time spans, making it incredibly challenging to determine their age in comparison to precise astronomers. We must keep an eye out for minute stars' light, and hue and contrast them with complex models of the evolution of stars. One of the most important methods is gyrochronology, which involves analyzing how fast a star spins, just like a spinning top that slows down over time. Stars gradually lose their rotation speed. By evaluating this decrease and comparing it to stars of known ages, mathematical models are available to scientists. Methuselah's age can be calculated without a doubt. Ancient and current measures. It is the oldest star that we know of, but rather than focusing on whether it might take longer than 2 billion years, perhaps we are older than the universe. We should flip the question. Could our universe actually be older than formerly calculated? Efforts to imagine that 13.8 billion years are not a small feat. Imagine compressing all of cosmic history into a single year, where the Big Bang happens at midnight on January 1st, Earth wouldn't appear until the final hours of the 31st of December, and all of human civilization's history would fill only the final few seconds of that imaginary year. Astronomers have determined the universe's age. by studying light from incredibly distant stars formed shortly after the Big Bang and factoring in redshift, an effect caused by the stretching of light as the universe expands. This data leads to the current estimates of 13.8 billion years. But a recent proposal from the University of Ottawa could ignore the assertions of the theory. The universe may actually exist. This daring idea dates back 26.7 billion years. It was introduced by physicist Rajendra Gupta, who revisited a theory from 1929 by Swiss astronomer Fritz Zwicky and paired it with Gupta's most recent insights. He suggests that over vast intervals of time, protons lose energy over distance, a notion that runs counter to how we now interpret redshift, rather than focusing solely on cosmic redshift expansion. According to Gupta, it could be a combination of factors. If true, this hybrid approach could completely alter our understanding of how old the universe really is, potentially resolving several long-standing debates, many of which have been brought to light by the recent findings from NASA's space telescopes, on which Gupta's theory is based. The tired light concept introduces something called evolutionary interaction constants. Originally, Paul Dirac, a theoretical physicist, suggested that the character of cosmic forces may have changed over time. It's important to keep in mind that our ideas about the age of the universe have significantly changed. In the 1920s, the universe's age was estimated by Edwin Hubble at approximately 2 billion years. Over the decades, more accurate observations have adjusted that number upward to the currently agreed-upon 13.8 billion. Whether we think of human history as a few seconds or milliseconds on the vast cosmic clock, there's no denying that the universe is beyond comprehension, and its ongoing expansion constantly challenges our preconceived notions. Meanwhile, scientists are making fascinating insights into our own galaxy. For instance, most recent data has shown that stars on the outer edges of our galaxy move much more slowly than stars in other galaxies. One theory is that the Milky Way contains less dark matter than we thought. Dark matter, though invisible, plays a major role in how gravity behaves on a cosmic scale. Another possibility is that our understanding of how dark matter is spread out across the entire universe is flawed. This mystery arises from information gathered by the European Space Agency's Gaia mission, which has charted nearly 2 billion stars in our galaxy. As a result of these findings, astronomers rethink how stars behave, especially near the Milky Way's edges. The speed at which stars orbit is directly related to the total mass of the galaxy. Gravity's grip depends on how much both visible and invisible matter exist. A recent study utilizing Gaia's data provides that the mass of the Milky Way, according to the data including gas, dust, and dark matter from stars, may be approximately 200 billion times the mass of our Sun, which is 5 times lower than earlier projections. This drastic reduction could imply a surprising lack of dark matter. Still, calculating a galaxy's mass is extremely complicated, and uncertainties in the satellite data or in the analytical models used may skew the results. As we assemble more precise data and advance better instruments, we'll keep trying to track these developments. Looking ahead, future technological advances in space missions are likely that enlightening many of these unresolved cosmic puzzles. The James Webb Space Telescope, with its unrivaled power, is pushing science's boundaries in a way never seen before. The mission goes much further than just estimating the ages of stars or the universe itself. Additionally, it reveals the internal workings, bizarre properties of galaxies, dark matter, and the unseen forces shaping the expansion of the cosmos. The evolution of the universe remains a major mystery, but as new data become available, we might learn that our long-held assumptions were either incomplete or wrong. A crucial question remains: do the laws of physics we rely on work the same way across all scales and locations? And what about the possibility that the universe's age is influenced by hidden forces or unknown phenomena that affect how galaxies behave and how stars age? with the sharpening of our instruments and more capable individuals emerging. Breakthroughs that shake the foundations of contemporary science may be on the horizon. Experts are starting to realize we are only scratching the surface in comprehending dark energy, dark matter, and the fundamental interactions that govern the cosmos. Every new observation, from ancient stars to faraway galaxies, provides clues regarding how the universe works. But these clues frequently produce more questions than answers. The ever-increasing likelihood that stars could have existed prior to the universe, or that the cosmos itself is much older than we thought, prompts a complete revision of modern cosmology. It suggests that brand new physics, innovative theories, and possibly a totally different way of viewing the fabric of space and time may be needed. These changes affect more than just scientific models. They strike at the very core of philosophical inquiries regarding reality and our position within it. If discoveries are confirmed, they could completely transform what we think we comprehend about existence itself. Discussions about the true age of the universe continue to rage. It's becoming increasingly apparent that we are beginning a new era in cosmic exploration. The decades ahead may bring clarification to questions that have puzzled thinkers for a long time. Whether it's finding stars older than the known universe or resolving the mysteries of dark matter and dark energy, these forces continue to hide truths just waiting to be revealed. The journey forward is all about testing, refining, and questioning our comprehension of everything, even beyond our tiny blue planet. Even though we do not yet possess all of the answers, our search for knowledge is just getting started. So stay connected for more updates on these incredible revelations and emerging theories. Keep your curiosity burning, because the future may uncover astonishing breakthroughs. If you're passionate about space science and wish to remain informed, subscribe to our channel, click the like button, and turn on the notification bell so you never miss an important update as we travel further into the depths of the universe. We stand on the brink of game-changing discoveries. The James Webb Space Telescope has already delivered mesmerizing images and data about remote galaxies, distant planets, and other celestial marvels. But this is only the beginning. As it continues its mission, Webb may reveal information that completely redefines our grasp of how the universe works. One of the most exciting aspects of this investigation is the ongoing search for extraterrestrial worlds that could harbor life, with a growing number of exoplanets discovered in the so-called habitable zone. The possibility of life beyond Earth is more plausible than ever. Even the detection of simple microbes on another planet would change biology forever, rewrite our theories of evolution, and alter how we perceive our role in the universe. On top of that, the investigation into the mysterious forces of dark energy and dark matter will push the boundaries of physics as we know it. These unseen forces make up most of the universe's mass energy content, yet we still have very little understanding of how they work. Solving these problems could open up entirely new layers of reality. Simultaneously, astronomers are continuing research into the behavior of galaxies. For example, the unexpected finding that stars in the Milky Way's outskirts are not moving as quickly as expected has already necessitated a new assessment of existing models of galactic dynamics. This may indicate that the Milky Way and possibly other galaxies contains less dark matter than assumed. If true, it could alter our understanding of gravity and the structure of the universe. This is a perfect example of how fresh evidence can make significant changes to established scientific beliefs. We are also expanding the idea that galaxies evolve in ways we haven't fully grasped yet, emphasizing the need for a more sophisticated approach to research. Could the universe be significantly older than we think? Are there elements of its story that models have yet to reveal? We've barely begun to uncover the answers. Astronomers will keep chasing these big questions as more data pours in from present and future missions. With every new development, it becomes clearer than ever that our current understanding is just the beginning. There is still so much to investigate, and the more we learn, the more we realize how much remains unknown. This never-ending drive to discover the truth and ask deeper questions is what powers the human spirit of scientific exploration.